My name is Scott Phillips. I'm an account executive over here at Honeycomb. Had the pleasure of working with the NS1 team, and it's been really exciting to just kind of see the team hit the ground running and some of the things that they've been able to do. So I am going to pass it to my co-host, Jessica, and I will let her do an introduction as well.
Thanks, Scott. I'm Jessica Kerr, Jessica Online. I'm a developer advocate here at Honeycomb. I'm very excited about distributed tracing and improving the worlds of developers and SREs everywhere. And today we get to hear from Nate and Chris at NS1, who are out there doing this in the real world and doing some very important life critical work. Nate, do you want to say hi?
Hi, yeah. So I'm Nate Daly. Nice to meet you all. I'm head of architecture here at NS1, but I've played many roles that have given me, I think, a unique perspective on what we do and how we do it and how we could do it better. Brief bit of context on NS1. We do authoritative DNS, which is very unsexy but extremely critical entry point to nearly all of the internet traffic that exists. So most stuff that you try to do anywhere that involves a network first involves looking up a name. And there's a whole big system out there that basically leads most of those requests to us and a small number of our competitors to answer. And our claim to fame is that we answer in a very dynamic way. So we have technology we call the filter chain, which allows you to introduce pretty complex but easy to understand decision points in every individual DNS lookup. So our biggest, most important customers are those with the most critical real-time traffic steering needs. So we have, most of the big properties I can think of online depend on us in some way. If you do anything with your phone or your TV or your laptop, you are using us constantly. We've done things like, I'm not allowed to talk about what I was about to say, so I'm not going to use that as an example. Just remembered the NDA on that one. But, everything from, businessy things like Salesforce and Box and Ignite and things like that to stuff that everyday people are using, Netflix and other streaming services and so on. And so much traffic is originating with the NS1 authoritative lookups that if we go offline, this is the joke about, it being life critical. Someone will die somehow. I'm not entirely sure exactly how, but
we can't live without the internet sometimes.
It's very critical, and if anybody happens to remember, they call it the dying apocalypse in DNS land, but in 2016, around when I was joining NS1, one of our competitors, Dyn, went hard down and took Twitter offline for an extended period of time. And the basic point about DNS is you can make your infrastructure as redundant and reliable and highly available as you want, but if nobody can look up twitter.com, it matters not. Recently, Facebook also had a DNS related issue that I believe involved engineers driving to a physical location and cutting through locks to get into a place. So DNS is pervasive, usually not that interesting, but we do some pretty interesting things with it.
To be fair, I think that was BGP, but close enough.
But DNS was involved.
That's right.
All right. And
DNS is involved in everything.
It's involved in everything. Yeah. So we're trying to make the internet better at the end of the day by doing DNS better and doing innovative new things with it. And if you want to imagine what we really do, the way I usually think about it is this. The area under the curve of the harried mother of three who just got home from work, put the kids down to bed, and is sitting down on the couch and is trying to watch Netflix. If we can save her 5 seconds of frustration and we multiply that by several quadrillion unique individual experiences per month, the amount of good that we do in the world, if we do our job well, is incalculable. The flip side of that is if we do our job poorly, the amount of harm we can do is also incalculable. So it's a long lever to do good or ill in the world through the quality of our efforts. And that's one of the reasons we take performance optimization seriously and are engaged with Honeycomb. I want to introduce my colleague and partner in crime, Chris Bertinato. Chris.
Yeah, thanks, Nate. I don't have much more to say than what's written here. I'm a lead engineer and architect here at NS1. I've been here half as long as Nate has, but it seems like forever. So, which I think is just as just a statement of the depth of the kinds of problems we can run into here. So I'm happy to be here.
Great, great. So let's talk. Chris, tell me about one of those problems.
Yeah, well, I mean, I suppose some of the, I guess half of those problems, or maybe some portion of those problems, is not much different than what most other companies that work on the internet experience, which is we have an API, and so do most people. And so if you can't access the API, then you really only have half the system, because that means you can't make changes to anything. So your DNS lookups might still work, but forget about trying to change those things. So those problems are fairly mundane when you think about it. They're just things like slow requests, bad requests altogether. So I'm talking about like 500 level responses and things of that sort. And though that's half of it, I'd say, of the kinds of problems we deal with, and that propagates. I mean, those problems can originate from anywhere in the system. It doesn't have to be just like a faulty request handler. It could be a number of systems down, right? So like many other, even smaller and larger, how do I say it? Software-based companies, we run some number of services to accomplish the task, and so a failure in any one of those, depending upon how well we've dealt with failures in between the services, can eventually bubble up to that. So the surface area that we're typically looking at is either API requests, the success or failure of them, and then of course requests on the other end, which are DNS requests, success or failure of those. And so trying to understand, the problems are generally centralized around trying to understand what those failures might be. And given that they can originate, those problems can originate in any number of systems, subsystems.
Yeah,
that's the challenge.
Suppose it maybe more generically, right? We have similar structural problems to any mid to late term startup, right? You've had generations of developers, you've got lots of different signal, you have lots of aspirational goals with not a lot of clarity about how technically to achieve those and so on. And, in the managed DNS space, we're not looking to be a managed DNS provider, we're looking to be the best. And the path to superlative status requires constant effort and tooling, it turns out, because we have not exactly a microservice setup, I call it right-size services, but we have many services talking to each other through internal APIs. And at a certain point, the complexity exceeds the capacity of individual engineers to effectively trace through by hand and determine where bottlenecks are and so on, right? And so Honeycomb and distributed tracing generally is a hugely valuable tool for working with distributed systems and identifying bottlenecks, because if you've ever had this happen where you have 4 or 5 related services that are all backing one sort of customer-facing thing that isn't fast enough or reliable enough, when you try to assign that task internally, make it fast enough or reliable enough, you have essentially assigned an investigation, and sometimes an unacceptably open-ended investigation. And what we're trying to get out of is that, right? So we aspire to have the fastest, most reliable API in the industry, because like I said, what we do is targeting customers who need real-time control over their traffic, and they control us controlling their traffic through our API. So we have individual customers that make upwards of 1 million API calls in a day. And we have a lot of demand on our API, and our API is indirectly driving a lot of internet traffic. So it's very critical that it be not just on, but super fast, right? Because the agility of these large enterprises depends on their ability to make their changes realized in our system through our API as fast as possible. So kind of the question becomes, if you're trying to move beyond the table stakes of like, it should be on and working, and progress towards
little bit better than uptime.
so progress towards something that's superlative, right? Like all of you work
Yeah.
at companies, think about when your salespeople walk into a room, they want to say, hey, we have the best X, Y, and Z. How do you go from a good enough X, Y, and Z to the best X, Y, and Z? Well, you need some sort of internal discipline, right? You need more than just stating the goal. You need some ability to measure and improve the measurement that would lead to that. And so Honeycomb for us is part of our attempt to address that problem, right? We're also addressing the problem that the system's too complex for individual engineers to rapidly identify bottlenecks and address them. But along with improving our ability to do that, we're trying to improve our ability to garner kind of generic internal agreements between teams that line up with the business imperatives to create this superlative service. And so we're using Honeycomb in, I think, maybe a slightly different way than is the usual fare around SLOs in particular.
So SLOs,
Yeah.
Is this what you use to measure the speed of your API and know whether you're improving it or?
So one of the things you bump up against, I'm sure anybody who's tried to do availability SLOs and talk to any of their engineers has immediately had the engineer come back and say something like, well, what does up really mean?
Exactly.
It turns out, speed, there's a similar question. And once you aspire to be the fastest of something, it raises the question, what is fast, right? Is it P99? Is it average? Is it some blended metric? Is it the whole thing? Is it just part of it that's mission critical? Like, what do we mean by fastest? And so I think part of what we're doing with our SLOs is trying to determine a way that engineers can define in practice what they mean by fastest for the product team, right? Because the engineers are right up against the system and they know what to measure and what certain things result in terms of portal experience or success of a customer workflow or that kind of thing. So a lot of SLOs, I think the Honeycomb kind of philosophy is that an SLO should represent customer experience in some way, such that if it's being violated, the customer is experiencing pain.
That can be
And
internal customers too.
We're also working on that level, but those tend to be large numbers, like large single numbers that represent a whole lot of data, right? And the problem remains, right? We're not naive. We're aware that we should be driving our decisions with data, and we've attempted to have SLOs of that type internally before. And I kind of love studying failure and coming up with strategies to avoid similar pitfalls myself. And when we tried this previously, it wasn't because we didn't understand the model. It was because we made a couple of key mistakes. And the key mistakes I think that we're trying to correct for here with Honeycomb are these. One, the SLO is primarily not about telling the engineers whether the thing is slow or not. It's primarily an agreement between teams that we're going to do something if we don't meet this objective. And so the first mistake we made is we didn't make the SLO primarily about an agreement between the resources themselves and the people who are directing the resources. The second mistake is that even if we had done that, the agreement is too large to be effective, right? So if I say that, hey, I have an API, it's backed by an aggregate, maybe 12 different services spread across multiple Kubernetes clusters. And there's some async stuff happening, and there's a couple databases and caches in the mix and so on. And hey, I want it to be 99.99% available, and it's only 99.5% available. I have all the signal. I did all the right stuff. I'm making a data-driven decision. But what am I left with? I have to tell engineering, I don't know, make it better.
And engineering will say, and what features shall we delay in order to make it better?
Well, there's that, right? There's the fact that you constantly have to compete against the feature velocity narrative, right? Which at a startup is particularly intense. So this is really a question of how, in the midst of our running to get out ahead of the industry and build new features that are exciting for our customers and improve customer experience generally, how are we sticking to our commitment to improve performance over time and continually improve the availability and reliability of the system?
So that at the same time that your API is getting more powerful, it's also getting smoother to use.
Right. So the kind of SLOs we're starting with Honeycomb are from the other end of the spectrum. It doesn't represent customer pain if you violate it. It represents less customer joy than intended. right? So we're starting by setting pure latency SLOs around, we're calling them micro SLOs. So we're going through our API and per endpoint, per HTTP method, creating latency targets and creating burn alerts for those SLOs. And the idea is we get a couple of things out of this. First, we get an effective net to prevent us from falling, in the usual way with the slow erosion over time. You add new features and you don't know if you're regressing on performance, right? Now, when we do a deployment, we can see, because the burn rates will change pretty instantly if we've regressed on performance, and not only if we've regressed, but where specifically we've regressed. And we can make a decision now to roll something back or to close out a scope of work. Frequently the motivation for some teams within a company is to just check off, like, we did the work, we did the work, we did the work, we finished the project, right? And performance tech debt is usually invisible. Like, if you didn't finish a feature where the customer will notice, like, I can't do X, that's like the most simplistic kind of tech debt. Everyone can notice that that's there. But if you finish the thing and it's deployed and it's all functioning correctly, but it made some API endpoint 5% slower, no one will ever notice if you don't have this kind of visibility. And that wouldn't necessarily be customer pain yet, because that still could be well below the pain threshold. And that's why I mentioned up front that if you have like superlative aspirations, you need to do something a little bit different. You need to have some kind of internal discipline. And if you
Something
can,
more than nobody's complaining.
right, because you'll get into the nobody's complaining territory pretty quickly once you get your technical stuff together. The question is then, how do you keep up the momentum and get to the point where it's better and better and you have a culture of continuous improvement?
How do you
So-
maximize customer joy?
So yeah, exactly. So what we're doing is, we're first going to like get full micro SLO coverage for latency and tweak it to the point where it's not noisy, right? And just kind of set the baseline. And that gives us a way that, first of all, we can stop any bleeding. Like, we'll know if we're regressing, and we can have the high level agreement to do something about regressions before we do anything else. But then we can talk with the product team and say, hey, let's set a percentage improvement target, right? And we'll express that in terms of tightening these specific latency SLOs for these specific parts of the API. Now we all know what we're talking about, right? We already have the machinery in place to make sure that when the work gets assigned, it's extremely specific and it has all the information. So one of the huge...
And people will know how to do it. You mentioned being able to find bottlenecks. Tell me about that.
So I've been shopping this around with our product team because, like I said, this is primarily an agreement. Within NS1, product holds the keys. They control resourcing and resource allocation, right? It's a little bit different everywhere, but someone holds the keys, right? And so you need an agreement with those people. And I mentioned the agreement with a more traditional, like, big number availability SLO is too large, because then product will say, well, what am I agreeing to? What's the scope of work? How many full-time engineers for how long, right? So we're actually starting backwards. The agreement that's palatable to our product team is 1 dev for 1 day. So they're willing to agree with the architecture team that we can treat SLO violations as a special class of work analogous to, for example, security vulnerabilities that show up, right? Everybody knows that the security team gets a special pass if they say, we did a scan and we have this vulnerability. Okay, well, depending on what it is, we either need to do it right now or we need to do it ASAP, right? And it's treated as a special kind of work. Our intention is to get it to the point where SLO violations are treated as a special kind of work, but you still need the product team to understand what they're committing to. So we'll know we've succeeded if 1 dev in 1 day can either optimize it because they see what function, they see what database query, they see the actual arguments, it's the specific customer, the specific DNS zone, this specific time of day, all this stuff. Either they optimize it in 1 day because it's simple and they have all the information, or they scope it out, kick it back to product, and we can prioritize a larger scope of work. But the agreement is basically...
SLOs are giving you the measurements and telling you when, and justifying, no, we need to work on performance now. And they're also giving you the details that you need to find out where that performance improvement needs to happen.
Well, we suffer from what I think most, engineering teams would suffer from with this complex of a system, that you can benchmark all you want in lab environments and it doesn't accurately approximate production. So the other big initiative that we have for the architecture team, we call it the Test and Prod initiative. I have the Test and Prod shirt, and I really like it, because another tendency over time is, and I hope some of you can relate to this, they will develop kind of an ideological battle. The engineers will want to deploy more frequently, and everyone else will want more quality checks before you deploy, right? Because you're trying to limit the number of incidents, you're trying to limit the number of escape defects. And we ask a different question, because it's obvious that there's a diminishing return on your efforts if you're trying to just limit escape defects. And I'm sure if you've ever been in this conversation with an engineer and the product person says, I want no more incidents, the engineer just says what?
Welcome to reality.
Well, that, or fine, I just won't make any more changes.
That doesn't fix it either.
Like we won't deploy anything, right?
The rest of the world will bring them to you, the incidents.
And so the problem with focusing on just the one half of the equation of like, how do we catch things before they're released, is that it converges on releasing nothing. The ideal of that philosophy is you never release anything, because you can't fully test anything outside of production to ensure it won't behave badly in production. The only way to ensure it won't behave badly in production is in production. So that philosophy converges on less and less deployment, less and less work being accomplished. So we try to ask a different question, which is, when we release a defect, how painful is it?
Right.
How quickly do we notice? How quickly can we roll it back? How specific is the impact versus, large magnitude impact, right? And so we're trying to decrease the pain for escape defects, make it so they're quicker to notice, quicker to fix, quicker to roll back.
Not so scary.
Not so scary, right? And we have had lots of conversations. There's lots of ideological battles here, but one of the sort of ideological battlegrounds is around staging, right? Because staging is one of those things that can turn into, basically, again, it converges to something nonsensical. For your staging environment to accurately find all of the issues that would happen in production, it has to be production by definition, because you'll get, first, all the services are stood up. Oh, they're all talking in the same way. Oh, they're all at the same version.
Talking about DNS. I mean, there is only one DNS, and it's the world.
Yeah. So, another thing is we do progressive deployments. So Honeycomb is a way for us to detect performance and other behavioral regressions in a canary that's receiving no production traffic or very limited production traffic, right? So Honeycomb and our aspirational internal SLOs can be used as a gating mechanism for promoting canaries for a new deployment and that kind of thing. But the point is basically, I think Honeycomb is very much on the side of recognizing that production is where production issues are exposed.
Yeah, your customers are testing in production. Are you looking at the results?
Yes.
Nick asked a question. I think it's probably good to go into this a little bit, right? The question was about how the internal discussions are actually going. And I would say interesting from my perspective, because I'm usually the one who's railing against staging environments. And along the lines of what Nate has been saying with regard to what we intend to do or what we'd like to do, the argument is always go something like this. Tell me why you need a full replica of production to do what you want to do. And then most of the time, actually probably almost all the time so far, there is never really a good justification for it, because it's pretty contextual, and I think there is a fallacy in thinking that you can have a single environment to test all the things. First of all, because it's impossible to get to complete replica, and it's sort of possible in smaller cases if your system's small enough. As you get larger, it becomes nearly impossible or extremely expensive, not only in terms of infrastructure but in terms of people. So it becomes unrealistic at very least, if not impossible. And so the discussions are always around what do you need to do, and then what do you need to do it, what you need to prove it, and because there is nothing that gives you 100% certainty. I think that's the point. And it's not a very hard argument. It's not a very hard thing to argue against, because the lift for trying to create a replica staging environment is so huge that you almost always have to fall back on something else. And the benefit you get is so the returns are diminishing once you get toward like some level of staging, right? You have I think to use the example Nate gave, right? You have like, okay, you get the services stood up, and then now you replicate the service mesh that you're using, and now you have the same exact backing database and things of that sort. But now you have to replicate all the traffic, because that's a factor too. So once you start getting that high, I think that the returns become diminishing.
Yeah, I think,
And so, yeah,
Chris, the returns start to diminish specifically when you move beyond it matching the shape of production into it matching the content of production, right? So
yeah,
you'll know you've wandered off into the useless weeds when someone's like, we need all of the production data in the staging environment.
right.
Because the next question they're going to say is like, well, we need to replicate all of the production traffic against the staging environment too. And it's like, wow, okay, you're just too afraid to work in production. So let's address the reasons let's address the reasons that you're afraid to work in production. Usually it's something about visibility and control, right? So it's not that staging's not useful, it's that the boundaries of its usefulness are not clearly demarcated, and use of something like Honeycomb and leaning into a test and prod philosophy forces that conversation to happen.
And who is afraid of production? You've mentioned to me earlier that in the past, when there's problems in production, there were only a few engineers who could troubleshoot it across services.
Well, it's a bit of an art form, actually identifying performance bottlenecks in a distributed system, right? And with Honeycomb, like when we first got Honeycomb set up and got our stuff instrumented, there were a few of us who were just like, I'm just going to look for slow stuff. I don't even know what I'm looking for. Just find me anything that took more than 5 seconds, because stuff shouldn't take more than 5 seconds. And it's easy to do open-ended investigations like that. And I think we've gotten rid of all the stuff that came up in those initial searches. But I think it's not so much that people have trouble debugging in production, it's that if they don't have any visibility into what the problem is, right? At that point, we roll back, and then somebody's left trying to reproduce a production issue outside of production.
Oh, and then you're stuck with the
That's the
staging
real
problem
problem.
again.
So
because you don't have the visibility in production that you need
exactly
without the tracing.
If you deploy something goes wrong, customers are like, hey, this is bad, and you can't see it, that's your only choice. Roll it back, hand it to somebody, and it better be an expert, because they're going to have to try to reproduce a situation that only exists in production, right? Because usually by the time we've gotten there, it's been tested in staging and in local development environments and things like that. And so any of the low-hanging fruit and correctness, that would have been caught. So there's some factor in production. So for example, one thing that shows up in production that doesn't show up in any of our staging environments is there's a whole lot more row locking contention in the database. So you get traces in production where it starts to open the transaction and then nothing happens for a second, and then all the stuff starts to happen. And you're like, well, what's it doing here? Why is it spending more time here than it's spending doing the actual work, right? And if you see that enough, you know where to go look. Yeah, so
just to answer a question that came up in chat, Nicolas, if I pronounced your name correctly, if by progressive deployment of a service you mean when we roll out canaries, the answer is yes. So canaries are by almost by definition in production. It's just that only a percentage of traffic is going to those canaries. So if there's a problem, some customer will feel it. It's just the impact will be minimized.
But you'll have attributes on the spans that will tell you.
That's right. We do. Yeah. So we know exactly which pods are canaries and which are not. So in Honeycomb we can tell. In fact, we have a board set up that compares It has basically graph side by side for canaries and stable, so we can see if there's a large difference between the two.
Nice. Nice. On your performance improvements, Nick, I wanted that there's a graph and I want you to tell me its story.
All right, I can tell this story. So
Your
I am a lover of very small optimizations that make a big difference. So I'm always looking for what I call cliff graphs. And somewhere to the right here in the dead section, I had made some small improvement that I thought was the hotness. And I was trying to go find the improvement in Honeycomb. And I was first looking in just the space that looks flatlined to the right. And I was looking back, like an hour, like 2 hours, and I'm like, there's no data here. This is broken. I can't find my improvement and there's no data. So I messaged Chris and I was like, hey, can you look into this? This looks broken. And he said, no, they made a change to the tags implementation the other day. I think it's just that fast now. And I'm like, oh, BS. It went from like, it's obviously doing stuff to it seems like it's not doing anything.
3-second average
clearly,
over here on the left.
Clearly broken. There's no way that improvement made that much of a difference. But if you look, sure enough, there is data on the right. And what was missing was I didn't have the deploy markers turned on, which is what those dotted lines with the little circle at the top are. This is one of the more useful things to do, by the way. Lining up your tracing data with your deployments is hugely valuable. So Chris, he said, no, I'm pretty sure it's the improvement that they made the other day. And he told me to turn on the deploy markers, and you can see we did a deploy right at that moment and thing just flatlined. But this is representative of one of the valuable pieces of Honeycomb to me. If like Honeycomb does just enough stuff, just enough of the right stuff, that I see the possibility for us getting to this kind of utopia where the Honeycomb graph, the SLO, the trace, whatever the Honeycomb artifact is used first as the demonstration that there is a problem, right? And so you go to product and you say, see, this is bad. This is being violated. This doesn't match what we agreed on as an objective, whatever it is. They assign it. The engineer sees the problem. They drill down very easily into like where it is. Hopefully they fix it. And then the same graph, the same query ends up being the demonstration that the problem was resolved. Because the other problem with product team scheduling kind of internal engineering work that's aspirational in nature and not feature-facing stuff is they then need to tell their bosses how they spent their resources effectively, right? They need to demonstrate that they made a difference in the product.
Yeah, that demo is super easy when you're like, look, here's a checkbox where there wasn't one before. This is a demo. The graph is a demo.
Yeah, and one of the really useful things for this is the little, like right above this graph to the right, there's this compare to. And you can do 1 day prior. You can just pick some time period. And when I work in, a lot of what we do other than this, we have various log and metric data stores, and we end up using Grafana as our single pane of glass. I can't tell you the number of times I've sat there and made a second panel in Grafana that's the same view a week ago, so that I can like show somebody, this is what it looked like before, this is what it looked like now. And I was actually doing that in Honeycomb months and months ago. And I was showing Chris, I was like, I had 2 honeycombs up and I'm like, look, this is what it looked like. This is what it looked like. And he's like, you can just click compare. So that's really useful. I think, one of the other valuable things about Honeycomb to me, it's easy to notice aberrations, right? So Chris, you sent me some graph the other day where it's like, hey, look at this. There's a heat map and it's dense down here. There's some outliers up here, but there's this like repeated sort of angly inchworm thing happening, right? Any human who looks at that will be like, that looks different. And so one of the things I'm interested in is democratizing the identification of anomalies. So when I joined NS1 6 years ago, it was a much simpler system at the time, and we had fewer data stores, much less data to look at. It was very common for our customer success team to actually be the ones who would identify a performance anomaly or some sort of aberrant errors that were occurring, right? Because they have contact with the customers. The customers say, hey, here's a clue, I'm having this experience. And then they go start looking at graphs, right? And they'd be like, hey, this spike looks bad. Is this bad?
Like in Grafana?
Yeah, or we've also used Kibana, but the point is the customer success team was involved in policing the system. And now the system has become more complicated, and trying to put together valid views of what's happening with our other systems is expert work. Whereas, our customer success team, even the product team, is able to use Honeycomb. They're able to understand what they're looking at. And a big part of that, frankly, there are other ways to do distributed tracing, and there's other open telemetry systems and so on. But Honeycomb's ease of use, when I first started using it, I raved to them about this. The fact that everything is type ahead in the UI, right? Like I went in and I didn't even know what I was looking for. I'm like name equals, and I like typed a character, and it's like, these are all the names in the data set. I'm like, oh, I needed to know almost absolutely nothing other than how to log in to start using it. And that's really powerful. And I think that comes from the simplicity. And the other thing is the collaborative features have been really helpful. So I noticed over time, engineers used to, and they still do this occasionally, like we're not entirely in utopia yet, but in order to convince another engineer in Slack that we have some issue, they'd post 3 or 4 or 5 different links, like look at this dash, look at these logs, look at this thing here, check this out, we have a problem. The Honeycomb Slack integration is one of the nicest features, because you drop it in there and it will display this nice, like, this is what the query is, here's the graph, and so on. And dropping a Honeycomb link now can replace a whole bunch of things and be a convincing argument to another engineer, like, hey, look, there's a problem. And then the other engineer can go look on it, browse around, all of that history is saved. The fact that you can share, links to, how do you guys put it? Right, the views persist.
The permalinks?
Yeah, the permalinks.
Yeah, those last, they outlast your data retention. They last forever.
Yeah, that's really useful. But it's overall a very collaborative tool. And, just on that point, Chris, I remember when we were first onboarding engineers and getting them accounts, it was one of the easiest.
Oh yeah, right. I mean,
Wasn't
I think, right, it was like, here, click this link, and two
And bam, they're
seconds
in.
later they're done. Right?
All good. And another thing that's important to us, we tend towards the GitOps style of managing our production environment. And so we want people to be able to play around in Honeycomb and set up stuff and experiments and create their own SLOs for like one-off projects they're doing or whatever. But we also want to have kind of our blessed configuration. And so we keep that in Terraform and Git. So I've also used Terraform, like all of our micro SLOs, and we're working on making some of our more important boards also.
Okay, so and in the meantime, they can play around in the UI, but you have your canonical configuration where you can reproduce it.
Right.
Mm-hmm. Yeah.
So and the Terraform integration has been great and very easy to use. So that's important to us too.
We're at about 15 minutes till, so please, if you have questions, put them in the chat or speak up, either one. In the meantime, Nate, how did you, and Chris, what triggered you all to think about bringing in Honeycomb?
Well, I mean, I think the most obvious trigger was that we hired some engineers who had worked places previously that had distributed tracing as part of their stack in one way or another. We had people who had worked with homegrown stuff where they were storing their spans and doing God knows what to analyze it and make it useful for themselves. And we had one person who had both the experience of doing homegrown and using Honeycomb. And he advised us very strongly, don't try to do it yourselves, just use Honeycomb. But I think we've talked about this, Jessica and Scott. Once you've worked on a system that has distributed tracing instrumentation, I mean, let me put it to you this way. Creating a DNS record sounds easy if you say it in English. If you say it in a distributed system, it may be a call stack of 40 functions. If you're a new engineer and someone says, that's not fast enough, your first question is like, well, what's all the code that's being executed, which in total is not fast enough, right? And it can take a while, even with a good IDE, to like discover that. Or you could go in Honeycomb and you get the one trace and you go, oh, this calls this, calls this, calls this, calls this, calls this in this order, and this took this long, and I see the whole thing. So
You
it's
can see what
actually,
executed in parallel and what waited on the other one.
it's some of the indirect value is that you can take engineers who aren't trained in the system and get them oriented very quickly, right? Because of the fact that the traces are laid out the way they are, you can see what's happening in what order, and that ends up being its own kind of onboarding and saves the engineer time of having to work through that. Because as an engineer, as an older, stubborn engineer, like I will typically, when I have to optimize something, I use Emacs, I open a file, and I start writing down on this line in this file, this function calls this, calls this, calls this. I like write the whole thing out for myself to get it into my head. And I end up basically reproducing what you have in like a shitty text-based form.
That no one wants you to paste into Slack.
Yeah, so yeah. And usually with GitHub links, which then get out of date and stuff. Chris just added something, a span processor to add we're to our source graph in GitHub from the spans, I believe. So we're trying very much to shorten that path to like, this is slow, give it to an engineer, they click on this, and bam, they're inside of a function, but they know what specific arguments, they know what specific details they need to be looking at to reproduce it. So back to your question though, how did we get to this? We didn't, like we sort of had an architecture team for a while, and then we reorged and we didn't have that function explicitly, and now we have it again in the form of me and Chris and a couple others. So the architecture team revisited is only about a year old, and I was in charge of kind of reconceiving that, and I reconceived that in the form of our job is to lower the cost of development, right? And the cost comes in several forms. Obviously, it can take money to develop things. There's the suffering of untold dozens, how painful it is to the engineers to do the development. But most importantly, there's how much time does it take? And there's how much time it takes to produce a feature. There's also how much time it takes to produce quality. And we're trying to reduce the cost of all of that. And when we look at how expensive it is to do different kinds of work, it's disproportionately expensive to do optimization work in a distributed system. And Honeycomb helps level that playing field, right? Because if
so that more people can do it.
Well, if you think about just like human incentive structures, if you leave it the case that it's cheap and easy to add new features, but it's hard to make anything actually better that already exists, what will you do? You will add new features and you won't make things better. So this like shifts the balance back to where it's not significantly harder now to do optimization work on well-instrumented parts of the code, right? Because it kind of, it pushes it back towards what I think of as like interview puzzle territory, right? Where they put a single function up on the board and they say, given these inputs, this is slow.
And what makes it interview function territory is you can get a grasp on it quickly.
Yeah.
And the scope of it and the impact of different pieces. And that you mentioned lowering the cost of development, and a lot of it is time. But as a developer, the majority of that time is getting familiar with the code, getting that into my head. And if you can lower the cost of, okay, no, the code you need to look at is like right here, just this piece.
And it's more than that too, because the validation to your fix, right? So let's say you magically skipped all the investigation. Someone said, this is slow. And you go,
they gave me a failing test, for instance.
It's in that function right there. You go, okay, I can even see why it's slow. I changed this algorithm so that it's got a different complexity, and now it's going to be awesome.
How do you know it worked?
How do you know it worked? Exactly. And the usual answer is, well, I wrote a bunch of benchmark tests and I ran them in my local development environment. Okay, how do we know that the benchmark that you did in your local development environment translates to production? Well, it probably will. It must. My reasoning says it must. My reasoning is ironclad. Okay, so you deploy it and you're like, okay, based on Tom's reasoning, production is now faster.
That doesn't show up well in the product demo.
Right. So the product team now says to their bosses, Tom did something, he seems really confident. Right. So the whole kind of chain breaks, and it results in product not being willing to say, hey, Tom, go do more of what you do. So I think that it's very much, like I said, about this kind of circle of life between engineering and product. Engineering is in the position to know what to measure and how to measure it. Product is in the position to say, do this work based on these, business goals. But engineering needs to be in a position to say back to product, we did the work, here's the result, right? So, part of having the fastest, most reliable API is having numbers to back that up, right? So this is, even just using Honeycomb, I can't talk about who, but I've been on calls with customers of ours, and I end up talking to their engineers and so on. And we were on with one recently, and we have gone through a replatforming effort, and we had moved them to the new spiffier platform. And for them in particular, it wasn't spiffier in some way. And they were upset about that. And so we were able to easily see what was going on in Honeycomb in that particular instance. And we had it fixed within a day or two before I got on a call with them again. And we were able to say, look, the reason we were able to fix this quickly is because we use Honeycomb and have the core systems instrumented for distributed tracing. And it was very obvious where the issue was, and we assigned it right away. And they said, oh, we use Honeycomb too.
Oh, cool.
And in that 45-minute call, the most valuable thing I said was, we use Honeycomb, because their head engineer heard, oh, they make good tech decisions just like we do.
Wow.
So Honeycomb, is a best-in-class tool, in my opinion. And so there's a little bit of social proof that comes with leaning into using best-in-class tooling, right? We want to hire good developers. I ideally would like to leverage the good developers that we hire by giving them good tooling, rather than hiring good developers so they can be good enough to deal with the absence of good tooling, right? You can kind of do it either way. It's like, this is a sink or swim environment. We need really good people who can swim, or we need really good people because everyone here can swim and we want to do amazing things. So
then you can sail.
Yeah. And I think that for me, Honeycomb is like I said, it's more about getting to customer joy than about getting out of customer pain. And that requires discipline, internal agreements, social constructs, and the right tooling. And the fact that the SLO system allows us to say when and how fast something is degrading, and the degradation can be clearly understood through the tracing side of it, to the point where it's actionable by an engineer or scopable by an engineer, one dev for one day. That puts us in a position where we can really get the flywheel rolling and make it non-disruptive. Because if you don't have this kind of sort of micro agreement that we're going to do continuous improvement, what you end up doing is ignoring it for a long time, doing a whole bunch of work every 6 months, and then you have to do a spike, right? And I can't see people's faces, but I'm sure there are some people nodding.
And it's riskier because that is a piece of code that you haven't changed in 5 months.
Right.
It's not in your head anymore.
And we also have the kind of dream of, as I think a lot of techie startups do, of mega dash, right? When we really succeeded, I want to show up at work in the morning and just look at the one dash that shows me how well everything is going. So we're looking to lean into Honeycomb and get as much of our stuff there as we can. Not so it becomes mega dash, but already I have pinned in my browser our micro SLO page. And I started this morning by looking okay, what's burning at what rate? Let me go see if I can identify why it's burning faster than it was yesterday.
Fun.
Do we have any other questions?
Chris, thank you so much. I don't think there's any more questions in the chat, and we're almost out of time. So yes, everyone fill out the survey, put in the secret word. You too can test in prod. I mean, you can wear test in prod.
And try testing in prod too.
Here are some upcoming events. You can find these at honeycomb.io/events, I think.
Oh, can I add one more thing?
Yeah.
I mean, Chris hasn't even heard this from me, but I'm trying to get as much leverage out of Honeycomb as I can, mostly so that we can pay more and use it more, which you'll like. But one of the things Honeycomb gives us is, again, if you have kind of generations of services, you'll have services at different maturity levels, effectively. Some of them are better operationalized than others, some are more observable than others. And so right now in the API, we have mostly new stuff, but we have some previous generation code that's not instrumented and can't be instrumented the way it stands. And so this gives us a way to kind of add a level to the maturity ladder for services and say, okay, to be at the topmost level, it also has to be instrumented and hooked up to Honeycomb. And this gives us a way to say, when you're rewriting that legacy stuff, part of the value isn't just, you know, the language isn't supported or the security team says that there are vulnerabilities, but also we're going to get all of this new observability for that section of the system.
Which makes it way easier to change.
Yeah, but so it gives us a way to, you know, make an important distinction in the maturity of services internally, which creates pressure to get the less mature services up to par.
Nice. Thank you so much.
My pleasure. Highly recommend Honeycomb.
Yay. Scott, anything else?
No, I think you covered it all. Your recording will be sent to everybody, like I said at the beginning of the call. For any of our other events, like Jess said, you can visit our website, and we have a lot of really good ones coming up. But thank you everyone for attending today, and hope everyone has a great rest of their week.
Thanks so much.
Thanks, everyone.
Everyone.